We have successfully installed OpenShift cluster, and in last videos I showed you how we logged into our cluster using the web console and using kubeadmin user, and by using the kubeconfig file. And we can also log in by using the uh, command line and web interface both. So now we have to set up the persistent storage. So some storage class we want to set up with our Kubernetes cluster to make the things persistent. Whenever you will install OpenShift on-prem, so or by using UPI or even by IPI, so you must have to set up some storage class. If you are getting OpenShift services from some cloud provider, so that the installation is the responsibility of the cloud provider, in that case, the cloud provider will give you the storage class uh, built in inside OpenShift cluster. But whenever you are going to set up your own infrastructure, either on-prem or on cloud, you must have to take care of storage class. So today we have to look into the concept of storage class that we already did these some sessions on a storage class in Kubernetes. You can see those videos if you are confused with the concept of storage classes. So right now, our OpenShift cluster is connected, and if I would like to, I show you or see who am I is a command we can see. Right now, I am using with a kubeadmin user. Now, if I search for OC get storage class, so there is no storage class built in by default. So what we have to do now, uh, we will set up the NFS based storage class that we did for our Kubernetes cluster. To use the storage class as NFS in the OpenShift cluster, why we need it? Because we need data persistency, and we also would like to use in the further videos the OpenShift built-in image registry that also need persistent storage. And for the stateful set-based applications, we also need the persistent storage. So for this purpose, I am going to use a Helm chart. That's the same Helm chart we used for our NFS subdirectory provisioner, external provisioner we used. So this is the storage, the Helm chart we will use. And this is the way of installation of this Helm chart. But this is not straightforward in OpenShift, just like we did in Kubernetes, because OpenShift has a concept of storage. Uh, OpenShift has a concept of specific security, SCC, security context constraint. So security context constraint by default does not allow us uh, to set up any pod that can run with root privilege, any pod that can uh, use some advanced level of features that I showed you in the security part of Kubernetes, how we protect the Kubernetes. So it will deny the advanced level of security context. So if we go to this NFS subdirectory external provider, this is basically a GitHub project and its documentation is given here of this Helm chart. So in its documentation, it is mentioned how we can install using Helm. We were using customize, okay, and how we can manually deploy this without Helm chart, but directly by using the manifest, and how we can deploy over the OpenShift. So on the OpenShift, the details are given here, what we need to perform here. So on some installation of OpenShift, the default admin user does not have the cluster admin permission, but this is not in our case. Our kube admin has the full administrative rights. So it is recommending, this documentation is recommending us to use the administrator user that can perform all the advanced level operation on the cluster. So here you can see on the OpenShift, the service account used to bind volume does not have the necessary permission required to use the host mount and any UUID. So I showed you these two security context privileges. Mean host mount is by default not allowed as a volume in OpenShift, and any UUID is by default not allowed. But we need these two advanced level privileges to set up this uh, NFS storage class provisioner. So here it is the manual deployment process of this Helm chart on OpenShift. So here I just want to show you this command OC addm policy, add security context constraint to user. Okay, this security context constraint is allowed for a service account, and that in this namespace, and the name of the service account is this. So what is this security context constraint? I will do a detailed session, but right now you just have to make a concept, just you have to understand that security context constraint is giving you the advanced level of elevated privileges for any normal user or any service account user. So by default, Kubernetes is not providing the security context. You can run any pod with high privileges. By default, it's running with high privileges. But we saw in the Kubernetes security videos that how we can implement some namespaces. We can protect our namespaces with advanced level of security constraints. So we will do another session about SCC, but right now the concept of this whole command, this command is specific to OpenShift. OC Adam is not a Kubernetes command. It is specifically designed for OpenShift. And this security context is security context is allowed to this service account. So first of all, we have to, I will show you OC API resources. So these are all the resources right now OpenShift created. So you can see there are a lot of resources. But in fact, in Kubernetes, These all are not available. So some comes with the Kubernetes, but some are custom resource definitions that are designed by Red Hat to make Kubernetes more robust. So here, if I just do a grep over SCC, so SCC, security context constraints, is uh, is an API resource that is not a namespace leveled. That's why it's written here false. And its short form is SCC. And in detail, you can see and write it like this. So if I type OC cat SCC, so these are all the security context constraints that are configurable. We are not going to discuss this. I just want to show you that what is this a custom resource definition created by Red Hat OpenShift. Okay. Now, first of all, I will install this Helm chart, and then we will use this command to elevate our power in the OpenShift to run this chart. So to install this Helm chart, click here. And if you are confused with the Helm chart, just go to the Kubernetes deep dive and Helm chart videos you can see. So here, Helm I already installed. So Helm installation is not part of this course, but you can again refer to the same Helm videos. I just add this repo. This was already added here. So Helm repo list. So this is the Helm chart I added. This is the repo. This is the URL from where it will pull the manifest and all the values. And here, if I search Helm, search repo, and this is the name of the repo. So you can see there is only one chart in this repo. Okay. Now, to install this chart, we can use simply this command. Okay. But I will not use this command because when I will run this command straightforward in any namespace, that will be rejected. Okay. Because the security context of OpenShift will not allow us uh, to run this chart. So what I need, actually, I want to first of all extract, inspect values uh, of this yes, values of this repo and this chart. Sorry, INSPE. Inspect. So these are all the values. So I am going to dump all these values under a temp to some file. I can say NFS values, NFS chart values. Okay. Now under the temp, NFS chart values, we have to make sure some setting. We have to customize some setting to access this. To make this chart function. So it is asking for the NFS server IP. So our all master and worker node will access this NFS server as to the load balancer as an NFS server. I set up the load balancer as an NFS server. You can set up any other server that is reachable to worker and master node. But just to save time, what I did, I set up the load balancer as NFS. That will provide the storage for our NFS storage class. And here we have to define the path that the NFS shared path exposed by our NFS server. And this is good. And another thing that I want to show you, the storage class it will create. And default storage class, we can set this to default, but by default, it's good to not set this to default. And name of the storage class will be NFS, I can say SC storage class. And so these are some other values. You can also fine tune this Helm chart. Here, this deployment of NFS storage class will use a service account. So these are the resource limits that you must have to apply on the pod that will be responsible to provision automatically persistent volumes. So I am setting up the request 100, memory 128, CPU limit I can go up to max 500 millicores and 256, 512 megabyte of RAM. Okay, so there will be a service account. You can see the service account. So it will create a service account. Specify whether a service account should be created. Yes, it will create. And the name of the service account to use. If not set and create is true, a name is generated using the full name template. So it will create some meaningful name, but we want to know the name of the service account that will be used to set up this whole NFS storage class. So I can use the same name or any other you would like to, but I would like to use something meaningful, just like NFS client provisioner. Okay, so here I define the name of service account. So this service account will be created, and this service account will try to access will run inside the pod, or that will perform some advanced level uh, security privileges, use some advanced level security privileges. So this is done for our values. So another thing that I want to show you before deploying this, we must have to make sure our NFS is running. So on the same machine, what I did, I install NFS utils. This is my load balancer. It's already installed, and what I did, I export this NFS shared directory to all the IPs with no root squash. So this directory NFS share is created here. So what I need to add in the export chart, I have to define here the accurate path that will be reachable from all the master and worker nodes. So this is done. Now I must have to make sure that all my master and worker nodes have NFS client utility that can access, so that they can access the NFS share when any pod will request the storage class from the volume from the NFS. So just to show you, by default, the core OS operating system that is used by Red Hat OpenShift is uh, is built with built-in NFS client utility. So core user, I am going to SSH to, for example, my master node. Sorry. So this is my master node. And here, if I run show mount -e 10 10 10 1, so you can see it is queuing to my NFS server, and NFS share is reachable to this master node. Similarly, you have to make sure for all your master and worker nodes. And by default, it is installed, but maybe in your environment there is some firewall coming in between your load balancer and your cluster. So then it's a good idea to make sure all your master worker nodes are able to reach NFS server without any hurdle. Okay, so you will run the same command on the worker nodes too, but in my environment, this is the directly attached network with the load balancer of my OpenShift. So there is no restriction. But if your NFS is residing in some different network and OpenShift want to access it, then you must have to test this run. Now we have made our NFS server ready. We have fine-tuned our NFS chart values. Now it's time to deploy the NFS chart. What I will just use the same command. Just I will use install Helm install. This will be the name of the chart. I can say the name of the chart. I can say NFS subdirectory NFS storage class. And this will be the repo, and this is the chart inside the repo. And then these are the values used by this chart, and in which namespace it will do. I can create a namespace like NFS storage class and create namespace if this namespace is not already available. But this will not run until unless you are not going to run this command. So this service account from in this namespace will have a specific rights to perform the advanced level of functionalities in the pod. So this command NFS client provisioner and a namespace, I must have to create a namespace first because I cannot run this command without this namespace, I believe. So I will not run this command. I will first of all create a project, OC new project, and the name of the project is NFS storage class. You can also create just like NFS OC create namespace. So either you use OC new project or OC create namespace, both are same. So in OpenShift, the concept of namespace is called as project. Now we have to run this command. Okay, so now this service account in this namespace can perform these two advanced level of task functionalities uh, in any pod that will run by this service account. Okay, now it's time to deploy the chart. So same command I'm going to use. Create namespace I will not use. VLUES. Uh, Error converting YML to JSON. Okay, line number 95. I did some mistake. Let me quickly line number 95. Line number, yeah. I must have to remove these curly brackets if I want to use some values. Otherwise, if there is some curly brackets in this Helm chart, it's mean the default values will be applied. Okay, great. The NFS storage class chart is deployed at this time in this namespace and revision number one. Now, OC projects will list me down all the projects. So here you can see NFS storage class right now we are using. So whenever you will create any project, you will by default jump into that project in that namespace. You don't need to use every time -n while you are running OC cat pods and -n the namespace. So this pod is running inside the which namespace. You can run the command OC project. So right now you are using NFS storage class project. So whatever command you will run will go in this namespace in this project. So this is a new thing introduced in the advanced level of feature introduced by Red Hat OpenShift in the Kubernetes, that you can jump into any namespace permanently. So in OpenShift, the kubeconfig file is defining which namespace will be your default namespace. But here you can change it. So when I create this namespace, at that time, my project also shifted to this namespace. I will show you here. When I create this project, so now using project this on server. So you are now shifted to this namespace. Okay. So there are a lot of projects. These are all the namespaces. We will discuss these gradually whenever we will go through with all the latest topic of the Kubernetes. So everything is good. Let me just look all. So here you can see this pod is running, this deployment is running, this replica set is running, and is there any SVC? No. And okay. So if this pod is running fine, it's mean our NFS is reachable by cluster. And if I search for OC cat storage class, so this storage class is also created. And this is the total duration of the this storage class so far created. And reclaim policy is delete. We can change this value so that in case we when we will delete the persistent volume claim, it will delete the backend storage. So it should not be. So we will change this later. But right now, we just set up this storage class. Now we have to test this storage class. So let's go back to this documentation. And here definitely they give some, yeah, here. They give a manifest just to test either our storage class is functional or not. So I am going to create test storage class YML test PVC for storage class YML. So here I am going to put this one, and here the name of the claim is test claim, okay, and annotation, Not required. This is not required. And the name of the storage class we change to SC NFS SC. Read write many 1 MB it will demand. In which namespace it will apply? That project right now I am using. So I showed you OC project. I am using this project. OC projects will list down all the project, but OC project will show you which project right now you are using. Now I just need to apply this manifest OC apply -f, and it's created OC cat PVC. So you can see the persistent volume is created and bounded, and persistent volume is also created and it's bounded. Okay, so it's mean our storage class is working perfectly fine. And if I go under the NFS share, so here you can see this directory is also created by this persistent volume. Okay, so so right now my load balancer is working as an NFS, but if your NFS is running in somewhere else, you can verify from there. So we are good with this storage class. So in next session, we have to connect this persistent volume claim storage that we provision with our image registry. So how the default image registry, built-in image registry is running inside OpenShift cluster, and it is by default not able to save the images, or it is by default not running, in fact, unless you are not going to provide the persistent volume claim to the image registry, because it has to save the data permanently. So if you have any question, you can contact me by email. So in the next video, we will see this topic, persistent volume storage image registry.